Welcome back. In this part, we're going to take a look at assembly system calls. Okay, and in this part, we are going to concentrate on Linux system calls. Okay, so system calls are APIs for the interface between user space and the kernel space. And we have already used the system calls, which include the syswrite and sysexit. Okay. For writing into the screen and exiting from the program respectively. Okay, so let us take a look at the Linux system calls. Okay, so you can make use of Linux system calls in your assembly programs, and for that you need to take the following steps for using the Linux system calls in your program. Okay, and the first one is that you must put the system call number in EAX, okay, register. Okay, so from there you store the arguments to the system call in the registers EBX, ECX, and others. Okay, like that. Okay, from there you call the relevant interrupt. Okay, which is the int 0x8 or the int h. Okay, from there the result is usually returned in the EAX register. Okay, so let us take a look at this. So there are 6 registers that stores the arguments of the system call used. Okay, so these are the EBX, ECX, EDX, ESI, EDI, and EBP. Okay, so these registers take the consecutive arguments starting with the EBX register. Okay, and if there are more than 6 arguments, then the memory location of the first argument is stored in the EBX register. Okay, so let us take a look at this. So let us go inside our nano editor. Let us use nano. We're using nano. Then let us name it learn. Let us name our file learn.asm.assembly. Okay, so I'm going to show you some instructions here. So for example, if we use move EAX, okay, EAX into 1. So here we are moving 1 into EAX. Okay, we are moving 1 into EAX, and 1 is the system call number for sysexit. Okay, like this one, sys_exit. Okay, for sysexit, for exiting a program. Then from there we can use int 0x8. Okay, this one here, and this one calls the kernel. Okay, calls the kernel. Okay, so from there let us see. So here we are using the sysexit. Okay, we're using the sysexit. Okay, so from there let us take a look at how we can use the syswrite. Okay, so to use it we can move the EDX. Can move the EDX 4. Okay, so EDX will give it 4. So this is usually the message length. Okay, our message length. Then from there we can move ECX and then MSG. So this one is usually our message that we want to write. Okay, so we move it into ECX. Okay, so from there we are going to move 1 into EBX. Okay, like that. Okay, so we are moving 1 into EBX. Okay, so this is usually the file descriptor for standard out. Okay, for std out. Okay, so std out, I mean std out, like that. Okay, for standard out. Okay, for outputting. So from there we can move the 4 into EAX. Okay, and if we do that here we are calling the system. We are specifying a system call number for the system write. Okay, and we are moving it into EAX. Okay, so from there we can call our kernel. We can use that, or we can use 0x8, like that. Okay, so all the system calls are here. All the system calls are listed inside this path. Let us go there and I show you places inside here. Let me check. Let's go inside the home folder. Let us see if we find it there. So under file system, then let us go inside. Let's just do this. Let's save and then we exit, and then we go back to our root folder. Okay, go back like that, and then we are going to go cd usr, like that. We are inside. and then we can go inside the include directory, and then we use ls. Okay, we have many h file, okay, .h file, okay, which are called the header file. So we have many, they are very many, okay, but the one we want, let us look for it. It's called the u what, let's look for it. rstu okay, u is right here. It's called unistd, okay, it's right here, this one here. Okay, so all the system calls they are listed inside this header file, okay, together with their numbers. Okay, so here the value to put in exe before you call is the int 8h or the int 0x8. Okay, so we can, let us go inside, let us see if we shall see it. Let's just go down here in our terminal, and then we use nano. Let us use nano. It's called unistd.h, like that. Okay, so we are inside our file. Let's go back, let's go down here, and we want to search for something. Let's try to search for, so let us press Control then F. Okay, F, and then we try to search for, let's try to search for int, like that. Okay, so here we have many. So here we have int, we have define, blah 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 blah. Okay, so you can try to look for that number. So here we have X version, we have many. They are very many, guys, they are very many, but yeah, they are very many. Okay, so we can try to look for it. Okay, so let us go back, so you can look for it, it's right there. Let us just exit like that, and we can use grep, so we can use cut. Let us cut whatever in this file, and then we pipe it into grep, and we want to look for, let's look for 0x80. Is it there? Okay, so it's not there. Let's look for 0. Okay, we have many zeros. Yeah, indeed we have many zeros. So let us use sys. Can we use sys? Oh, we have many sys. Okay, so can we use sys underscore right? We don't have it. Okay, so we shall take a look at how we can see it, but I wanted to show it to you, but as if I'm missing out something. But yeah, we shall take a look at that in future parts. Okay, so after all, it's not useful in this part. It's not required. Okay, it's not required. Okay, so we can have a table here. I have a table. It's right here. Okay, as you can see, we have as you can see, ex 1 represents the system exit. Okay, as you can see here, and 2 represents the system the sys fork. Okay, 3 represents the sys read. So if you want to read or get the input from the user, we should move 3 into ex. Okay, so from there we have 4 sys write for writing. We have 5 for opening something. Okay, so and 6 for closing. Okay, as you can see there. Okay, so these ones are usually used when opening file and closing files. Okay, so like that. So let us have a simple example. So let us see. Okay, so let us go back in our home folder. Let us just type cd, and then we use the squiggle sign. That's squiggle sign, and then we are back inside our home. So if we print working directory, we are inside home user folder, and we can go inside. Let's go inside our files, like that. So I have a folder called files, and inside here I have a file. So if I press ls, I have a file that we are going to be working with, and I named it, what name did I give it? Is it called calls? Let me look for it. It's called system calls. Okay, .asm. So let's go inside nano system underscore calls.asm, like that. Okay, so now we are inside. Okay, so we are inside our Linux. Okay, so let us see what we are doing right here. Okay, so here under the data section, as you can see, we are defining our section, our data section, and from there we have this first message, user message, and this one is going to be a message, bytes. We are storing bytes. Okay, and we have please enter a number. Okay, so this one is going to ask the user to enter a number. Okay, so from there we determine the length. Okay, the length of the message, and here we determine it using equal keyword, then dollar sign, then slash. Okay, then slash, not slash, dash. Okay, dash, then our message. Okay, that we want to determine the length. Okay, its length. Okay, so from there we have another message. Okay, so this one we are going to be outputting what the user has entered. Okay, so here we have you have entered, and then the length of that message. Okay, so we named it disp msg. Okay, msg with capital M, as you can see, like that. Okay, it doesn't matter. Okay, any name you give it will work. Okay, so from there we have our next section called the bss section. Okay, so this one contains uninitialized data, that has that we haven't initialized. Okay, so and this one we have our variable called num. Okay, num, and then we are storing some bytes. Okay, some 5 bytes there. Okay, inside our num. From there we go and then we create our text section, or our code segment, or our code section. Okay, so from there we use the global keyword, these ones. Okay, main, we have our main label, and then this one is going to get us the user. We are going to prompt the user. We are going to ask the user. Okay, so to ask the user, we are printing a message. Okay, we are printing a message, which is this one right here. Okay, the user message. Okay, so we are printing this one. Okay, and in order to print out something, ex must be having the 4. Okay, must be having the 4. Okay, so from there the ebx must be having 1. Okay, 1 which is the standard out, and 4 which is the system right. Okay, call number, like that. Okay, so from there ecx must be having our user message, our message, and edx must be having the length. Okay, the length of that message, of this message that ecx is having, and from there we can call our kernel, like that. Okay, and we can read input from the user. Okay, so here we are going to read and store the user input. Okay, and to do that we move 3. Okay, which is the standard in. Okay, which is for inputting. Okay, for inputting. So I have here my table. Let's return that table. So as you can see, 3 is for system read. Okay, for reading. Okay, 3 is for reading, system read, as you can see right there. Okay, so from there now we have 3. We move it into ex, and then we move 2 into ebx. Okay, and 2 is this one that we have, struct beg ebx. Okay, so this one here, let me explain. So 2 means a standard in. Okay, means std in. Okay, so let me show you right here. So 2 is called the standard in. Okay, for inputting. Okay, standard in. 1 means std out. Okay, for standard output. Okay, like that. So we are reading, so we use the std in for standard input, like that. Okay, so from there we move, we give the message that we want, where we want to store that value that the user has provided. Okay, and we want that message to go inside the num. Okay, inside the num variable. Okay, the name variable which we declared. Okay, but didn't initialize this one here. Okay, so from there or the message length. Okay, or the value length. Okay, so here 5 bytes. Okay, so we have 5 bytes. From there we need to output that message, and in order to output that message, you know very well how we can output the message. So here we are outputting a message which is this one that you have entered, that one. From there, let's go back. From there, we need to output the number. Okay, so as you can see here, we can use int 080h. Okay, from there we need to output our number that the user has entered, and then yeah, you know very well how we can output. So this num is going to be our message or our text or anything that we are going to output, and then we move it into ECX, and then we move 5 into EDX. Okay, so which is the message length. Okay, 5 bytes. Okay, so from there we can call the kernel, and here we can write a exit code. Okay, so and as you can see here, we are moving 1 into EX. Okay, so this is the sys exit, okay, for exiting, and then we are moving 0 into EBX. Okay, so 0 means the exit code. Okay, the exit code, and 0 means success. Okay, and 1 means failure. Okay, so from there, so later we shall take a look at how EBX, okay, how moving 0 into EBX affects our system, or what it does. Okay, so from there we are going to save, and then we are going to exit. Okay, so we are going to compile our file, so we are going to use nasim. Okay, so use this command. Okay, so we are going to use nasim, and then -f elf, and then the name of our file is called system_calls.asm, like that. Okay, so from there we need to link. Okay, we need to link, and we are going to use the LD binaries. Okay, so we use LD-m -m elf underscore I386 space -a space -o, and then we need to specify our output file. So our file is going to be called system_calls, okay, _calls, and then our object file is called system_calls.o, like that. We press enter. As you can see, we are defaulting to this address. We don't care. From there we can run our program /system_calls, like that. We press enter. As you can see, enter, please enter a number. So let us enter 33. Press enter. As you can see, you have entered 33. Okay, so let us take a look at the system. Let us take a look at the exit code. Okay, so to see the exit code, we use echo, and then the $, then question mark. Okay, as you can see, the exit code is 0, which we put inside the EBX, okay, during exiting. Okay, so I told you. So what if we set, let us set can we set, let us try to set can we set, yeah, can we try to set $? Can we set it to be equals? Let us set it to be equals to 3. Command not found. Can we use the var? Is it, what is it? So let us try to, can we try something like this? No, here we are echoing. So let us try to get the system, the exit code again. Okay, using echo. So it's 0. It's 0. It's 0. So let us go back in our file. Let's go back in our file, and let's put 2220 inside EBX. Okay, we save, and then we exit, and then we try to compile again, to assemble again. After assembling, we link. After linking, we run. Let's run. Okay, so after running, get 4, then we get 4, and then we echo out our exit code for the last program. As you can see, it's 20. Okay, yeah, like that. Okay, so that's how we can specify the exit code. Okay, the exit code, like that. Okay, like that. So in the next part, we shall take a look at other concepts. Okay.